So we have two topics. One is kind of theoretical, like how to do the best matching algorithm, yes. And the second is another theoretical. Okay, so we matched two records. What shall we do after that? Should we merge, link? How we can handle this information? How we can, I don't know, handle the quality? Which topic would you like to discuss?
Well, I'm just going to say, I'm going to jump in. I'm happy if someone else does, but I don't really, the question of merging, if you were dealing with patient records and you needed to analyze them on an encounter level, then clearly you'd want to, if the encounters were different encounters, you wouldn't want to remove them from the data set. You'd want to keep multiples. If you're just trying to come up with a single record to represent a person, then you have a different question. You say, well, if you have some fields from one file and other fields from another file, you want to keep all of them, but maybe some of the fields are supposed to represent the same thing, be it the name or some other characteristic, and you don't want to keep all of them. Well, then you have to decide which one to take. So, it's, I had a problem like that at the Census Bureau. We brought together files and we would have these crazy meetings where people would say, well, you want to use the first name that you saw, or the last name, or this or that. And we had these discussions, but no one had any data to look at. So unless you have some data to drive to say which is the best, it's all speculative. But, if it's addresses, of course, why wouldn't you want to have multiple addresses? You want to know all the addresses they've been at. If, unless there's some reason why your database, you don't have the space to hold all that. In that case, you'd want to figure out which is the most recent address, which is the current address, probably.
Yeah, that's interesting. Always when we're talking about like merging, I remember CRDT data types. Yes, so maybe guys, you heard about this. It's conflict-free data types. And they essentially try to keep all the data. So the conflict-free data types, that mean that they can be edited on different nodes and they can be synced and then get eventually to the same result. For example, the Google Docs, it's an example of CRDT data type when multiple users can print and all of them see the same document. And I am always dreaming that in FHIR data structure should allow something like this. So when you're merging, you only add the information and it's accumulated maybe with some labels. But I don't know, Grahame, what do you think? Oh, we lost Grahame. Okay. Guys, anybody welcome to discussion. If you have some point of view on this, let's say, merging topic or linking.
Well, I think the problem statement sounded like there are two separate things from my mind, right? When we're talking about merging, we're talking about things about the patient's demographic, which name, which address. We want all their addresses instead of one address. When I'm thinking about linking, my mind goes towards longitudinal nature, right? Like ultimately, I'm less interested if I have all versions of your phone number. I'm more interested that the encounter, the observation, the diagnosis are all linked to each other, even if they may underlyingly have originally had different identifiers. So when we talk about merge and link, my perspective on the conversation is more about the events link. When I say linking, I'm thinking about linking the discrete events that happen to one actual physical person, as opposed to from a data presentation view of merging the demographic information about the person, because usually I'm using it for a clinical purpose. So far what I've heard, I think that, linking seems to be a way that if you're able to have a data structure to link, which kind of sounds like a cross-reference or a bridge table or something like that, then you have an easier method to unlink, to say that between these discrete clinical events that we think belong to the same person, and they have various different phone numbers, and I link them together because I'm looking at the patient treatment. If at a later point I realize that I should not have done that, those are some of the challenges I'm trying to address, sort of beyond the MPI, the matching issue. What are the things that we have to consider after the fact? So you'll have a certain percentage that is 100% sure, a certain percentage, 100% that they don't match, some in the middle that requires a manual intervention. Let's say that manual intervention takes place and the humans are always right. Let's say the software that did for sure it's matching is not always right, it matches it. I think that we should establish a link from that matching, because there may be a case where a human will say, despite your algorithm, something has indicated that these are not the same people. And if we have to undo that, what considerations should we take when doing the linking so that the undoing doesn't make the problem too complicated? So it's the split, this unfortunate split challenge when you unfortunately have a very confident false positive, sometimes by the algorithm, sometimes by the people, but it gets discovered at some point and it's very critical. What should we think about in terms of the FHIR data structure to enable us to send some sort of, message or information to say, unlink these because it's a mistake? If anyone has any thoughts on that or ideas, I'd be appreciated.
I think that we are in a space of trade-offs. Yes, so the link or merge, it's a trade-off. Yes, the question is when we should make one choice or another. Yes, what the condition?
Yeah, if I may jump in for a second, very interesting discussion. Thank you for having me. So the thing I heard from Thomas initially is the fact that you have to be able to reverse this particular linking. I wouldn't say merging, but more of a linking type of thing, because at some point in the future, if you realize, oh, maybe that was not the right patient, or maybe it's something, you have to have a track, an audit track, a forensic track. You can go back and say, okay, we linked patient A to patient B 6 months ago because this particular reason. We thought it's the right patient, but it turned out not to be. So you have to be able to backtrack the entire thing. And I don't know, probably legislation is similar in all over the world, but in Canada, this can constitute also a privacy breach. If I link patient A to patient B and I show you the full result and you realize, oh shit, that's not the same person, all of a sudden, that's a privacy breach and we have to be accountable. We have to be able to go back and realize, hey, why did we do it? And say, oh, Chris, maybe he put the weights wrongly, or I don't know, let's send Chris to prison or whatever that. So that's no. But see, at that point, you have to be able to go back in time and realize what was the event that caused the linkage and undo it. So, okay, that's my 2 cents.
Well, I'm going to make a suggestion that I think it's a real problem that you're talking about, but there's what I think is a pretty effective solution, which is you keep all the records that you originally had, and then you create a table of linkages, and the table of linkages will just say record number 22 links to record number 37, and the linkage was made by this linkage process, and let's say there's a score or a probability associated with them. So you have a linkage file, and then you're going to use that that linkage file, in real time, but you can update that linkage file, or you can run an alternative linkage analysis and create another linkage file. I mean, the important thing is, just like any data processing, you want to generally avoid throwing away information. You want to keep it, flexible. So that would be what I would think would be the strategy that you would want to use. And it doesn't take that much room to keep the information about the linkages. So, you just have to be able to hold the original records, because you don't want to throw away the information on those.
Yeah, but as I said, I still think that this is kind of trade-off. Yes, because if we can imagine that we kind of populated FHIR with a bunch of duplicates and link them, so then we're losing all the simplicity of FHIR API. Now we're going to work with a set of patient IDs. So, and everything getting much more complicated. Yes, from like user perspective. From logical perspective, we still understand that this is the same patient. This is one information. Yes, and this like kind of schizophrenia. Yes, that we have multiple instances of something the same. Yes. And what I can imagine, if you're writing some application which really using this data, yes, and want to manipulate, create some, do some care processes and stuff like this, you still can consider kind of merging idea or creating golden record, which is deduced from all the other records, but providing like synthetic aggregate of all possible data. And then working with this aggregated record as a one entity. And because I don't think that if you do the merge and keep the old history, you still can do unmerge. The question is, what if you get new information after merge? Yes. So when you unmerge, where this piece of information should go, to patient A or to patient B. And we have John. John said that there is a hot discussion in FHIR about merge or linking. John, can you join to us by voice?
Sure. Yeah. No worries. Yeah, and I point out the link. When it comes to patient level merge versus patient level link versus really a hybrid, which almost anybody who does merge ends up with some kind of a hybrid, is actually a very hot topic. And yeah, there's a bunch of points on the patient page. I point to it in the chat. And I think there's even more happening in the R5 space on that. So a lot of this discussion around link versus merge is very foundational to healthcare. If you're in healthcare, you know what merge versus link is. Those who come from outside tend to end up with a misunderstanding to begin with. But yeah, and to the point earlier made, the longer that a false positive is left in place, the far more likely a privacy or a safety incident will happen, and the less likely you'll ever be able to undo it. Because once that false linkage data has been used in a treatment scenario, you've now got new observations that have linkages to the false previous data. And now you can't just use your audit to undo. You also have to look at all new data created since that failed merge or link to see whether there has been any, uses of that data. So yeah, I think as you deal in healthcare, especially with clinical cases, you go at it with a very conservative approach. Now, I think there's also some discussions going on here that are very different in that, okay, if I'm going to be deduplicating data for the purposes of filling a clinical research data set, the risks are a lot lower. Or if you're dealing with a situation where you've got the patient handled, but now you've got to deal with deduplicating data, which is also in the main topic of Grahame's blog. The fact that the patient has across 10 sites the exact same COVID immunization, does that mean that they did get their first and second? Or, so it's the deduplicating of data that's the far more difficult.
Thank you, John. And Brian posted the link about the potential merge operation. Brian, can you sound it?
Yeah, I just posted it as sort of the background to what John was referring to. So it's more described the practicalities of the impacts, not the how and why you should do it, which is what the rest of this discussion's all been about.
Do you have any point of view on this? Your personal?
Not specifically. I guess not that's adding anything extra to what's already been discussed.
Okay, guys. Grahame, are you here with us? Maybe some questions. So we have a lot of experts. Yeah, we have questions from Vasil. Vasil?
I mean, it's not a question.
Opinion.
As John pointed out, we're talking about multiple things that are all very important. If we are talking from the FHIR point of view, if we're talking about a single FHIR server, obviously, what do you do if you created two patient resources for the same person, the same patient? And the two ways are you remove one and leave the other, or you link them using the link element and leave both resources there. And so when you merge something, that's when you get the issues of any links to the previous one should now link, any pointers to the previous one need to point to now to the other one, to the new one, or the correct one. And if you do this if you make a mistake doing this, then you should be able to redo, which means that purely from a FHIR point of view, you need to keep additional information around so that you can restore back. So the obvious additional information is having history. So if you have history of the resource, you can go back and see where it linked, where it was pointing to before the merge has happened, and so on. So this is kind of straightforward if you have full FHIR capabilities, FHIR native data on the same server. And the other problem that is the federated data is when you have 15 FHIR servers, each one is pristine, each one is very good, very high quality data. They all have the information about the same person. You can determine that it's the same person, but it's also the additional information that you need to determine whether that is the same. So now you have an explosion of resources, especially observations, that you need to know whether that blood test result, even though it was on the same day, does it have a right timestamp? Did you do do both servers have deal with time zones the same? Does one only store UTC time and the other stores Eastern time, even though the location is in Mountain time, and so on and so forth? All these details become really hard, and as I jumped in at the beginning, they get a little less hard if you can get an identifier that travels around and is not a single identifier, but identifier that is linked, that is issued by the source of information, and then you can then trace back and keep around with each copy on a different server of the same data, so that you can later determine that. In order to get to that point where you can safely look at 15 FHIR servers and know what to do with the data, I think we have to work towards that. It won't happen overnight, and working towards clean data in that sense is something important that kind of underlies all the work that the different implementation guides and different specifications that the build out need to think about when they build their application, their specification. How will my specification work when I have not just a single FHIR server, but I have the same information that I want to show in that I'm describing, profiling in my implementation guide? What if I have multiple servers that have that same information, but from different time points and different healthcare events?
Thank you.
So in the following Graham's path, here are the problems. Good luck.
Okay, guys.
Yeah, I think Grahame took way too much glee in presenting only the problems and not the solutions. That was just way too much glee.
But this is a half of solution. If you can formulate properly your problem, yes, probably you will find the solution. The question is, are we formulated it in the right way or not?
And definitely the use case.
Is it real problem which we are fighting, or maybe it's a phantom? So maybe it's symptoms.
National patient ID with digital identity assertions.
Something like this. Yeah, I'm thinking about Web 3.0. Yes.
5. Web
yeah.
5, right? Or 6.
Yeah, so we can say that this resource exists universally. Yes, it has their own ID. It has some signature by source which can be traced back, and it lives in some blockchain, so trusted network can access it. Yeah, and then we have the history of all the records which the whole network is agreed on. So it maybe sounds like dream, but I think maybe in 10 years it will happen.
You know, actually, you just broached on a point I was hoping to hear something about, but didn't. It's dealing with identity where the identity is fuzzy. Like newborns will often be given names like baby boy, and those names can last for a long time. And then there's also homeless people, especially if they may not even know their identity. And then there are people whose identities are unknown. They're unconscious when they come into the ER, and we just don't know who they are. They're assigned John Doe and Jane Doe. Finding that entity, very hard. Even if we had a national identifier that we could trust.
Mm-hmm. But for example, from research from anonymization, yes, we know that even if you don't know direct identifiers, you have a second identifiers, and potentially you can restore identity by the secondary features like medications, diagnosis, visits, and this may help in future. I mean, so you don't have to just have SSN or names. Potentially, I think a couple of visits, if you know exact time and physician, so it's identify with a high probability. So this is the same guy.
It's the reason I think
that I mean, we did look at this at NCHS. Yes, there are newborns are called baby boy and baby girl, and getting back to Chris's point, your editing process would recognize that these are not real names and take them out of the scoring mechanism. But assuming that you have the same dates of birth and the same house addresses, then there's a very good chance that you can identify who they are even without a name. Now you can come up with the edge case and say, well, that they could be twins. And yes, you wouldn't be able to distinguish those cases unless there was some other fact you can use. But you can do a very good job of finding people, even if the first name is something like like baby boy. That doesn't have to preclude being able to find a link.
Especially if you, for example, include mother's information and father, yes? So then it will be almost like identification.
I do
You're
think
always
that
going to have this issue, especially Flaggy Sunter doesn't have the flexibility to deal with, no, for the most part, doesn't have the flexibility to deal with hierarchical relationships. So you may have to add some post-coding or pre-coding to your process. So you may want to say, okay, this is a link. That means that technically when you say something is a link, what you're saying is that these are not a spurious match. Well, a link between two twin brothers is not spurious. That's what your probability tells you. You're going to need a second layer, which is going to say, okay, these are clearly related entities, but they have completely different first names. So I'm not going to say that they're the same person. You can add that on. Now, if you had a Bayesian model, you can incorporate that directly in your probability model.
yeah, it's those edge cases that make us favor linking over merging, because first of all, the identity match is never perfect, and then there are some cases where it's really difficult, and you're going to get data later on that will help you. You know, baby boy will eventually get a name, and if he has the same medical record number, you can be clear that you've named him well. But that data comes later. Linking makes it easier to bring them together later, or to separate them if you brought them together prematurely.
Okay, guys, I think we're out of time. So thank you, everybody. I hope this was interesting, and I think it was really interesting. So you're welcome to our Health Dev Hub Slack chat. So please fill the form and join, and to discuss something like this in a chat. That's my dream. Okay, and see you next time. So thank you, everybody. Bye.